All right, everybody. Hello and welcome to this part 3 of episode 1 of Boss Cranky's Coding Camp, all about defensive programming, aka the episode that never ends. Today, we're going to go into our third and final example of defensive programming, and it's going to go a little beyond what we've done thus far. Previously, we've done simple parameter validation. Today, we're going to get a little more detailed. The example we will be using today is returns fraud. And what do I mean by that? There are a number of different ways that bad actors can commit returns fraud. In the past, like say the 70s and 80s, that would involve going to a store, purchasing an item with, say, a check that they knew was bad, and then either returning later to that store or to a different store in the same chain and returning the item for cash. The vendor took what they thought was a legitimate tender type in the check, and then they gave back cash. The more modern example is a bad actor will use a stolen account, whether it's credit card or whatever it might be, purchase a number of items, typically services or items that are virtual rather than physical items, so that they don't have to take possession. An example might be hotel reservations. They come in to a site and they place a reservation using a stolen credit card, and then later the bad actor comes back and says, oh, I want to cancel that reservation. They supply a different account number to do the return against, which is their own legitimate account. They get the money back into their second account, which was good. First account was bad. The vendor, in this case the hotel chain, is left holding the bag.
Listen, these examples are really simple by design. I ain't teaching y'all to be criminals.
Yes, in this example, it is the hotel chain that loses money, but they pass that on to us as consumers. And once again, this is a super simple example. But as the man said, I'm not trying to teach you to be crooks. We're using this as an example of defensive programming for learning purposes and to illustrate how good intentions can sometimes lead us astray a little bit. So all that jibber jabber aside, let's get into some code here. We're going to look at this real simple test method here. You can see what it's doing is, well, actually it's pretty well named, I think. Purchase and return same tenders test. What we're doing here on line 76 is creating a customer with some properties here. I'd be willing to bet that that test email has something to do with ducks. Hey, look at that. It sure does. Look at that, little sister. There's our quacky ducks. So anyhow, we create our customer, make sure it's not null. I know that's overkill. I'm just a little OCD. We make up a mock tender. Then we get into our logic here, our real logic. Around line 86, we say, let's make a purchase with the customer, the tender, and an amount. I'm not going into items or anything like that, keeping it fairly straightforward, making sure that we were able to create a sale object, and then just sort of making sure that the amount on the sale is equivalent to the test transaction amount that we specified in the purchase. So the purchase is customer, tender, amount, and then we verify that on line 88. And then on line 91, we are going to return the sale. We're assuming the entire sale. Listen, you could add a lot of logic here about items and taxes and all that. We're not going to do that here. Super straightforward, just boom, boom, boom. So we do the return, we supply the sale and the tender. This is the use case we like. This is the one where we make a purchase on a given tender and we are returning to that given tender. Straightforward. That's what we're doing on line 91. We're basically doing some of the same assertions we did before. With the exception of the fact on line 93, we are saying, let's make sure that the sale amount and the return amount net out to zero. We'll take a look at the code in a little more detail in a moment, but bottom line is the sale has a positive amount, the return has a negative amount. And in this scenario, they should net out to zero. Also in this scenario, we want to ensure that our tender has a balance of zero because we charged an amount and we are going to return that amount. Let's run this test case and see what happens here. And it ran fine, no problem. We didn't expect issues here. This is straightforward. Where we start running into issues is when we're trying to be helpful, which normally isn't a bad thing, but let's see how we might start making things difficult on ourselves like we talked about earlier. Let's imagine a case where a helpful BA or SME or developer, any number of people might say, you know, what happens if somebody makes a purchase, say Friday, after they make their purchase, they lose their card, they call their bank, get a new card issued, and then next week they try to return the item and we're like, hey, you can't do that. Well, that's a bummer. Let's see if we can handle that case. The developer says, all right, let me just try copying the test case and see what happens. So we've got a purchase and return with different tenders test case we're going to do here. You can see initially it looks just like what we had before. Well, chances are real good this is not going to run, and it didn't, right? Line 125 said no, the tender dot balance is not equal to 0. Earlier we said if it's on the same account, the net should be 0 at the end of this. Okay, well, how do we fix that? First thought might be, well, let me just do something like this as a developer. So we've got the return, which is legit. We've got the tender balance, which is 0. Well, that's no good. Let me say, I'm not going to check the tender amount because I don't know what the numbers might be. Let me just say I'm going to make sure that the sale and the return net to 0. All right, that's almost certainly going to work. And look at that, it did eventually. So we might say, okay, well that's fine. They can do that. This is where our opportunity for problems come in. Okay, so how do we fix it? New implementation of this return method. So our old implementation of return simply says, hey, look at this. What we have here, parameter validation. Defensive Programming 101 Lesson A, right? We check to make sure our parameters are null. We do the credit, and then that's it. We return the new transaction, the return transaction with the original transaction amount negated, the tender amount, and the customer. But the credit here looks like, I'm sure this is pretty simple. Yeah, remarkably simple. We just decrement the amount by the amount supplied. So that's the original version. The enhanced version, the Gandalf version, if you will, says, okay, let's do our validation, which is groovy. And then it further goes on to say, what's this tenders are okay method? Let's check that. We take two tenders and then we compare them to null. Hey, we're still doing defensive programming with input parameter validation. But in this scenario, we're saying, are the account numbers the same? Well, if they are, then that's cool. And if they're not, then we have a problem. This is the default for most e-tailers. They say, if you're doing a return, you can't do it against anything other than the account that you made the purchase against. That's cool. I mean, that solves the problem, period. But it doesn't allow for the scenario we talked about of the person getting a new card, replacing an old card, and getting a new account. Okay, this is really kind of a complex problem to solve. Not so much because it's technically difficult, but because there are a number of options you might choose to solve it. You might just arbitrarily say, no, you can only return to the same account that you purchased with. You might say you can return to the same account, or you can return for store credit. You can return to a different account, any number of permutations there. Running the new test case, we see that it will fail, which is what we want because we're using two different account numbers. This test return account number is the return tender, my Hacky account, and the other account was this one, test account number. So cool. We have prevented that from occurring, which is good. Our assertion failed on the is not null here, which makes a whole lot of sense because we basically say you can't do that. The main takeaway for this entire episode is that as software engineers, we must think critically. We have to ask questions like, what happens if? We have to be willing to think outside the box. Otherwise, we're just chimps on a keyboard, and that's no good. And I know that some of y'all are thinking, boy, this is hard. How do we make this easy? Well, you know what? If it was easy, anybody could do it. And you're probably also thinking something like, you're just overthinking it. You're worrying about this way too much. Well, that's a possibility. However, I would say,
all right, some of y'all are still thinking, Boss Cranky, you crazy. I don't need to be doing all that. You're just overthinking it. That's your opinion, and I tell you what, to celebrate our differences, I'm going to offer you what's known as a chair shot. It ain't a drink. Give me just a second, I'll get it for you. Hang on. Come over here, and you get something like this, and you say, oh, I'm overthinking it, am I?